So in this video we assume that you created your scan and you have all the views that you need for your model. We will create a watertight model, and not only this, we will post-process the scan. That means use the EinScan filters for getting a smoother surface or make sharper edges and all of that stuff. So this video is about post-processing scans. So here we are right now with the merged and fused model, and you can see the good news is you capture a lot of small data. That is really nice, and you see that there is as well errors. So here is the markers positions where there was nothing below us. That is information that the merge could use. You have here a very shiny surface that was scanned, and of course it's possible to scan shiny surfaces even with much more expensive or advanced devices, but you will have always a problem of uncertainties because high glossy surfaces, they are emitting similar light that is projected to them. So any kind of software and detector will have problems even with coherent light, the laser or whatever, to identify exactly the position. But you see it's possible. You can smoothen that, whatever. It's just to show you what can happen. Okay, so we used automatically create some volume model and you see maybe this is not exactly what you wanted to have, because this is a turning part. This was a casted part where there is machine surfaces, and for sure they were not bulbing to the inside like it's here, so you don't want that. So to not have it, you don't, let's say, use that automatic mode. So you are going back a step, you create a not watertight model. And yes, I said before you need a watertight model to print and so on. But there is functions to create a watertight model out of this one after merging the surfaces. So again, there is some stress for your CPU. And here we are. We created a model, but this time it's not watertight. You will see the same surface holes that you've seen in the scans itself that was not collected by any scan. And you didn't see the bulbs that you have in the automatic merging so far, but of course you want to 3D print it like we assumed before. So we are going to close that. And here is a lot of different functions that you can use. You can of course again save the scan in its current state. That will save the existing scan how it looks. You can share it over different kind of the networks. In this case you can directly import it to your CAD software in Geomagic. I will cover that in another tutorial. Mesh optimization, holes filling is what we will need. Mesh optimization, I will not do it right now. You can sharpen edges, you can smoothen the surfaces, whatever. Do mesh simplification to reduce the weight of the model. Create multi-views and so on and so on. Texture mapping here is gray because we have not captured any kind of the texture. It's not working with laser scanning together, of course, so far. So hose filling, we want to have a watertight model. Okay, so you can click for auto. What will maybe lead to the same bulbs that we've seen before? Quite sure, because it was created on some automatic algorithm you have no influence on, or you can manually fill the holes. Let's do it. Right now you will see your holes, and you can repair them one by one. So I will choose tangent in this case. I pre-selected that already before. It stays selected in this case because I think it's a very good version to close that surface. It is really close to what you expect to be the shape. You can use flat. or you can use curvature. In this case I think I will have to go back. Okay, it's like Ctrl Z for going back. As a shortcut you will be able to go back in what you did. So let's close it in the flat way. You see here it is quite similar, but it has a bit different kind of the shape inside. Unfortunately, it's not exactly explained how mathematically this is, let's say, working. What I'm expecting, it's referring on the surface ends that the algorithm will find, and he will try in the flat kind of the modus, he will try to close that surface by some, let's say, surface that is going flat from the outside to the other side of the boundary actually. So it will be not following any kind of the curvature. That means if you have bended up edges or so, he will quite unlikely create such curvature changes inside the extrapolated points at least. Okay, so that was flat. Let's use curvature. And it still looks quite similar. There is some small changes you will see by the rendering of the edges of the surfaces, but doesn't matter. Each of them for me was better like the automatic modus, where you create some balloons to the inside. So I prefer actually to manually close the holes, at least the most important ones. You can as well, of course, close some holes that you think is important to you. We can do it in this example, why not? And leave some of them open, that is not so important. It can be a lot of holes depending on the quality of your model, and you will not want to fix the very small ones because they will be easy to find and detect and so on. So let's concentrate on the important ones. So yeah, let's pick up this one, this one, come on. Okay, that looks a bit strange to me. Maybe there is better option on flat. Why not? Okay, you see that is already a lot better like before. Here is as well some small areas that is not perfect. That look to me better in the automatic modus. How about these ones? Let's see. It's quite fine. I think it was better like before. Okay, so maybe let's close this one. This can be important for next works. This one. Okay. Maybe here we could have put a bit more time in the scan. Let's stop here. We don't have to do all of them. I think it was enough to understand the principle of how it is working at least. So, you see, it looks quite better than before. Okay, so as we have quite a lot of small holes that we kept here, we are, let's say, right now fed up with doing every small pixel, and we want to be sure that it's totally waterproof. So we are going to finish up with Autofill. What is, let's say, important here is that you will have to manually give the software a value that is the maximum length of a curve that he will accept as boundary for filling. So if you will, I can do that. Do here just a very small value and click on apply. He will just fill the very small holes that have less than 10 millimeters, I guess, of boundary length, and you will see it will not help you out so much. So you will go to bigger values. I will put something that seems to me more reasonable. and let's see if we will be fine afterwards. Okay, so everything's closed, even the bigger ones that were staying. We are fine to go at least. I think one of the things that is, let's say, still visible in this model is that, see, it started from the positive side. It's for the money a really gorgeous scanner, but of course comparing it to some Creaform product or so, there is differences. I was using Creaform for a test scan, and something that you will see is that if I putting the markers inside the edge here, you will not have that kind of the killing of the edges. I'm absolutely sure I can correct that in some post-processing software, but it's not necessary. I would like not to do that. But on the other hand, if I think about buying a scanner that's in the range of, let's say, 40 to 50, 55,000 euros or the equivalent in dollars, it should be quite in the range. Or if I'm buying some product that's with some really cool geometric essentials and some Siemens CAD software, you can see that here it is already installed. It's a solid edge. It's a bit, let's say, a smaller license like the full version, but it's permanent, so you don't have to pay for every month, and you will see in the later tutorials it's really worth. And all of that will go in the price, let's say a bit more than 10, 12, 13,000 euros, dollars, depending on where you will buy it. It's really, I think, some compromise that you can live on. I recommend, if you start scanning and you are marking your object that is necessary for the laser scanning, before start to scan, think about where you're going to put your markers. So in this case, for example, I was putting the marker on some cast surface that have no function. It doesn't matter for me so much if there is some impreciseness. As well, I can scan that areas where the marker is from different views, so you will have that missing information that will create here some interpolation. That means some filled up surfaces that is not real scan data. It will be there from some other view. It means, of course, putting the new markers and taking off other ones, but if you really want it, you can do that. But for me it's fine. I know that I have some limitations here, that most of the cases doesn't matter, so I put the markers in areas that is for your later on work, not really important, and you are absolutely fine with that. On the other hand, you see here that even with the not maximum resolution of that scanner, you really get a really good result. And it's waterproof. Okay, so creating the model. Let's do a bit, let's say, post-processing. In the post-processing you can get, let's say, some result a bit optimized. I'm using aftermarket software mainly for that, but even with the onboard extras for this, you're absolutely fine. I'm just always, if I want to find out how something works, I'm doing some variation just on one of them, see what is happening, and I try to figure out what is the combination or the tool that I want to. In the case of the smoothing, it means that to see how it works and how it will react, I just do some quite of extreme example. What is actually in this case not so extreme as I would have expected it. You see that the peaks in the mesh are gone, at least there is a lot less of them. It seems all a bit more glossy in the rendering, that means that small details of the cast are reduced, and that's it actually. So I'm going to reset, because I don't want to apply a change on a change, and I'm going to smoothen it, let's say 50%. I think to do a smoothening much less, not sure if it's worth, because it will mean I'm not doing anything, so in my understanding, but yeah, let's test it. Sometimes it's in software a bit counterintuitive. You have sometimes some values that you adjust, you would expect the total difference, but here it's not the case. You see, there is really some sharpening effect that if you reduce the smoothness, it comes back again. So in this case, I don't see a really huge benefit in a small sharpening, so let's do something like 89, whatever. In this case, I would use that one. Okay, but let's not start with the change on the change. As I said, we will do some single parameter variation. So sharpening. In this case, you already don't have that parameter bar that you can drag and drop. It's just some 3-level change. So let's start with the maximum sharpening. Let's see what will happen. Okay, so this was the maximum sharpening. I don't see so big differences. Maybe we are creating some screenshots. Sometimes this really helps to get some impression on it. So let's see what happened. Okay, so yeah, there is some effect, but this area here, I see a little bit of different glare, but not so much. Okay, so let's apply. Maybe it's sometimes an option to do one and the same effect. Let's say a filter. It's always some filters that will calculate the mesh in a new way. Looking at the topology on the surface, and depending the magnitude of the topology change applies some kind of the algorithms. So if they are, like in this case, not too strong, sometimes it can be useful to do them second time. That means we will apply the sharpening that we did. So that was calculated on the mesh, a change in the mesh regarding the differences that the software will find. So we will apply on the changed modal another change, go to high, say apply, and let's see what will happen. That means sometimes if you are not happy with the result, but you see it's going in the right direction, it's like iteration of the process. It can help if you don't want to use a third-party software for mesh processing. Okay, another iteration. We see the area that we had previously, and cut the lines off, and you can see that there is some change and it's getting better. Of course, if you apply it more times, you will get to better result, and the surfaces will turn more to surfaces, and you see that as well. The errors from the markers are getting less evident, but be aware that sharpening, of course, is not make the general basic result necessarily much preciser, but it can make it, let's say, more suitable for what you want to do with it. Let's close. Okay, so smoothing, sharpening, hose filling, everything's fine. Mesh optimization is a good question actually. This is a really huge topic for working with meshes, and it's cool that there is a tool for it, but it would be really nice to know what it's doing. Mesh optimization should in the best case as well avoid, let's say, meshes that are, let's say, scrambled into each other. That means you can have visually here some edge, but sometimes if there is errors below the surface and the triangulation is creating some nonsense surface, it can happen that you will have here a lot of small surfaces difficult to see, but they are there and they are creating a lot of strange surface that will stress your import routine in other software. So detection of this kind of the strange noise that is put to some new surfaces, or as well triangulation that could be, let's say, following some standards and so on, is all topics for mesh optimization. But I don't see, unfortunately, exactly what it does, but let's test it. It will not get worse. In the mesh optimization, it's not necessarily said that you will see with the eye a very big differences. Okay, so mesh optimization done. Let's see. Of course, compare the same errors, but it's really visible. In this case, you can see that here there is disappearing a lot of that surface noise. There is some tendency, in my opinion, to see triangulation a bit more, especially in this area. But it seems really better. What else actually? If we are talking about simplification, we can make the result smaller. Therefore, I will create some export. Sorry, I don't want to share it, I just want to export it. Here is the normal scan formats. I think most commonly used is STL. I'm going to create some export folder. I would be really happy if that would have been saved in the same folder by default, but I have to choose it again. Okay, I have already created here, and I will not export it again. I just will show you how it looks later on. And this can be done by show you guys how to import a scan into some non-project. That means there is no drag and drop or automatic opening of STL files based on the software if you click on them. So if you have no other STL viewer, not necessarily the software will open up the STL file like it's another scan software. But don't bother, it's not a problem, because you can, even if you just have a STL file and want to optimize it with the software, that's free of charge and it's included in the scanner, and you can install it on multiple PCs. You can use that software anyway. So you can go here and you say, I'm opening a merge, and you don't need any kind of the scan results here before. Just enter into some project data and jump directly to post-processing. Go here and opening file, choose some compatible file like STL and so on, and you will be there. And you can see the results that was created before, and you see that this is high resolution, and we can open a smaller one that is less than half of the size. That was done on a mesh simplification. Let's store it. You can scale the model, you've seen that just a moment, maybe I was doing that too fast. Sorry for that one, I'm going to override it. You can scale the model, so it means if you want to print it half size, you can put here just 50% of the size. It's volumetric scaling, but I didn't use it anytime. I think it's very few cases. If you have a foundry, you are, let's say, a wax caster, or you are doing some kind of other casts, maybe in some plastic as well casts, and whatever you can have in vacuum casting, there can be need for it. And it's cool to have it, but actually I never use it, so I'm exporting it one by one. Just for the last point, show the export. In the red bundle you will get some Geomagic license included, and here we are. A plugin is directly transferred to the Geomagic software. And here we are. You have to choose millimeters. You can use some auto repair. I'm not going to continue here. It's not the task for today to speak about Geomagic. It will be for next time. As you can see, okay, the model looks quite well, and let's continue on that topic in the next video.